If you've ever coded in Python, you've definitely used lists. They're great, but when you start dealing with huge amounts of data, those trusty lists can really slow you down. Today, we're going to talk about the library that completely changes the game for high-performance computing in Python. Let's dive into NumPy.
You've probably used Python lists for, well, everything. They're super flexible, they're easy, and for smaller jobs, they're perfect. But what happens when you're not dealing with 10 items, but 10,000 or a million? All of a sudden, that flexibility becomes a major bottleneck. Your code just crawls, and you're left waiting. And that's the exact problem we're here to solve today.
So how do we shatter that speed limit? How do we take on serious numerical tasks without the frustrating lag? Well, that brings us right to our first topic, understanding this very real need for speed.
And the answer, my friends, is NumPy. It literally stands for numerical Python, and it is the absolute foundation for pretty much all data science and machine learning in the Python world. You can think of it like this. It's like taking your standard family car, that's Python, and dropping a Formula One engine into it. Suddenly, you're ready for the racetrack.
Okay, so here's the core difference, right? Python lists are kind of like a mixed bag of candy. You can throw integers, strings, whatever you want in there. But that flexibility comes at a price in performance. NumPy arrays, on the other hand, are specialists. Every single element has to be the same data type. This constraint lets NumPy store them way more efficiently. And this is the kicker: perform math on the entire array at once. It's incredibly fast. So when you're working with numbers, this specialization gives NumPy a massive advantage.
All right, so we get why NumPy is so much faster, it's efficient, but how do we actually start, using it? Well, that's exactly what we're going to cover next. Let's start building with NumPy arrays. Getting started is just ridiculously easy. Seriously, pop open your terminal and type one single command: pipe install NumPy. And that's it, you're done. Then in your Python code, you just import it. And see that as NP? That's a universal convention. You'll see NP used as the alias for NumPy in basically every tutorial, blog post, and code base out there. The simplest way to make your very first array is to just convert a Python list, something you already know and love. You literally just pass that list to the np.array function, and bam, you've officially got a NumPy array, ready for some high-speed action. It's the perfect bridge from what you're already used to. A lot of times in data science, you need to set up an array of a certain size before you actually have the data to put in it. This is where placeholder functions like np.zeros are a lifesaver. You might be setting up a grid to hold, say, the pixel values for an image. In this example, we're creating a 2x3 array. That's 2 rows, 3 columns, filled with nothing but zeros. It's a clean slate, just waiting for your data.
If you've ever used Python's built-in range function, you're going to feel right at home with NumPy's arrange. It works pretty much the same way. You give it a start, a stop, and a step size, but instead of giving you a lazy iterator, it gives you back a full-blown NumPy array. So here, we're getting an array of all the even numbers from 0 up to, but not including, 10. This is super handy for creating sample data or an axis for a plot.
Now this is where NumPy really starts to flex its muscles, handling multidimensional data. See how we're passing in a list of lists? That simple trick lets us create a 2D array, which is really just a matrix. This basic structure is the foundation for representing everything from spreadsheets and images to the really complex data sets you'll find in machine learning. Okay, so we can make arrays. That's a great start. But now for the magic. This next part is where you're probably going to have that aha moment and see exactly why NumPy is so indispensable. Let's talk about supercharged operations. The secret sauce, the core concept behind NumPy's speed, is something called vectorization. So instead of writing a Python for loop to chug through each element one by one, which is like taking a slow, winding country road, vectorization lets you perform the operation on the entire array all at once. It's like switching to a 6-lane superhighway. Your code is cleaner, and it's all happening behind the scenes in highly optimized, low-level code that is just blazing fast.
I mean, just look at this comparison. It says it all. With a regular Python list, if you want to double every number, you have to set up a new empty list and write a for loop to go through element by element. With NumPy, you just take the whole array and multiply by 2. That's it. One line. It's cleaner, it's way more readable, and it runs orders of magnitude faster. That, right there, is the power of vectorization.
And working with your data is just as simple and elegant. NumPy uses the same slicing syntax that you're already familiar with from Python lists. And remember, indexing always starts at 0. So here, we're grabbing the elements starting at index 1, all the way up to, but not including, index 4. This is an absolutely critical skill for pulling out the exact slice of data you need from a huge data set.
NumPy also comes packed with a whole suite of what are called ufuncs, or universal functions. They're called universal because they can operate on every single element of an array without you ever having to write a loop. Need the sum of everything, the average, the biggest or smallest value? There's a simple, super fast function ready to go. Think of this as a handy little cheat sheet for some of the most common ones you'll use.
So you've got the building blocks, and you've seen the superpowers. Where do you go from here? Look, learning NumPy isn't the final destination. It's the launching pad. And that brings us to our final section. Your data journey begins. Honestly, we've only scratched the surface today. You can do so much more, like reshaping arrays into different dimensions, generating all sorts of random data for simulations, and this is the most important part. NumPy is the backbone for other essential libraries. It's the engine that powers tools like pandas for data manipulation and matplotlib for plotting. It truly is the key that unlocks that entire data science ecosystem.
So if there is one single thing to take away from our time here today, it's this. NumPy is not just another library. It is the foundation. The moment you get comfortable with NumPy arrays and vectorized thinking, you are officially ready to start tackling almost any data problem the world can throw at you.
And with that, we're at the end. But really, the most important question is the one for you. Now that you've had a peek at NumPy's power, its ability to handle massive amounts of data with incredible speed and elegance, what's the first big problem, the first complex analysis that you are going to solve?